Hello guys. Okay, so today we will start chapter number 4, and I have divided chapter number 4 into two parts. So in this video we're going to discuss the first part of chapter number 4, and chapter 4 is about authentication. I hope you guys are already familiar with authentication, the definition of authentication, factors of authentication, and some other stuff like the password things and all that. So we will be discussing the transport layer authentication methods, schemes, and formal authentication methods in this chapter. So we have 4 agenda items in this chapter that we're going to talk about. The first is just to recall the definition of authentication. So what is authentication? How we can perform authentication and stuff like that. Just a basic overview. The second agenda item is we will be talking about factors of authentication. Factors of authentication, like you can also say elements of authentication, like knowledge-based authentication, username, password, and all that stuff. Thirdly, the most important topic, it's called types of authentication methods. Types of authentication methods, and that's basically what we do on transport layer. Transport layer, this is the application layer. We will discuss that, what's the difference and where exactly we use these. The last thing that we will be discussing, this is basically what we're going to talk about in our today's video. This is the part 1. And in the part 2, the second video, we will be discussing some formal authentication protocols. And 3 main protocols that we will be discussing. First is the Kerberos. Some of you guys might already heard of. We will discuss Kerberos, OAuth 2.0, and the last one is HMAC. So hash message authentication code. So this is basically what we're going to discuss in our part 2, the next video, okay, in the next part. So today we will discuss definition, what is authentication, factors, how we can perform authentication, especially application layer, and the last is types of authentication methods. So we will be discussing 3 types of authentication methods. So the first is, first we need to understand what is basically authentication. Then I'll explain you the difference between factors and types of authentication methods. First is the definition of authentication. So authentication, if you recall the definition, like for example, we have 2 people. Like say this is computer A and this is, for example, computer B. Okay, so they cannot see each other. For example, it's let's say it's facebook.com, for example, and you want to access facebook.com from your computer. If you want to access facebook.com, so the problem is that how they can authenticate you, like you just send a message, hey, hello, this is computer A and I want to access my account. I want to access my account, want to make some settings, upload a picture or something like that. How Facebook can authenticate you, verify that this request came from you. In order to do that, what we do, we actually use our Facebook assign you a unique username and a secret password. Okay, so Facebook assign you a unique username and a secret password. So whenever you make any request to facebook.com to access your account or stuff like that, you will send your username and password. When this username and password will get to facebook.com, they will consult in their authentication server database. And if they find a matched entry, they will allow you to access your account, otherwise not. Got it? That's a typical way to perform authentication. Now the thing is, when Facebook, for example, respond you back with a result, how you can make sure this request came from Facebook? I'm getting a point. You need to know that, like I have received this message and it came from facebook.com. So when you send any request, like how we build a trust model, like if you access something, if you want to access facebook.com, how they can make sure it's you. And if Facebook send you something, how you can make sure it came from Facebook. This trust model is called mutual authentication. Mutual authentication, where we user authenticate Facebook or receiver, sender authenticate the receiver, and receiver authenticate the sender. This is called mutual authentication. So let's coming back to the definition. Definition of authentication is going to be, it ensures that individual, or you can say individual or computer is who he or she claims to be. Claims to be, not an imposter. This is called authentication. Okay, and there are plenty of ways how we can perform authentication, like plenty of elements that we can use, that whether it's you or not. So those elements are called factors of authentication. Now, what is the factor of authentication? Like, there are 5 factors of authentication. Most of us, we are familiar with the first authentication factor, which is called knowledge-based authentication. Knowledge-based authentication. And knowledge-based authentication is basically they authenticate you based on something you remember, something you memorize. Like, for example, if anybody wants to, for example, if this is you, and how Facebook will authenticate you based on, let's say, if they implement knowledge-based authentication, username and password, like something that you can remember. So it's username and password, or PIN code maybe. So for example, user ID, username plus password. That's the best example for knowledge-based authentication. Most of the websites, they, like you can say 100%, all the websites, they use knowledge-based authentication, roughly. Second factor of authentication through which we can authenticate the user, that is called token-based authentication. Now, what is token? For example, token could be real tokens, like, for example, the small devices which you can affix in your keychain, which send you a random PIN code and all that. It has been obsolete nowadays. So because cell phones are very common nowadays, like at GGC, once you send your username and password, they send you a PIN code on your cell phone, or they actually call on your cell phone number. So that's a token. Cards, ATM card, credit card, debit cards, you can say your RFID access-based card, they also fall in token-based authentication category. So token-based authentication category means something you have, and here something you know, like your username, password. Third is the factor authentication is the biometrics. Biometric-based authentication. Biometric-based mean like your Face ID, for example, your fingerprints. So something unique in you. That is called the biometric-based authentication. The fourth one is the passive authentication, location-based authentication, your IP address or your geolocation. So it's the passive type of authentication. Like, you don't actually provide anything, no input, nothing like that. But whenever you access the server from your computer, they actually see your IP address and location. You might have seen this location-based authentication. For example, if you access your Gmail account, for example, from any other state, any other city, any other country, they send you email. Like, for example, if you access Gmail account from any other state, they will send you email like, we have detected unusual activity from your account, and if it's not you, just click here, something like that. That's called location-based authentication. Last is called action-based authentication. It is also becoming very common. Like some companies, they have started collecting your keystroke, like the way how you type your password, like your typing patterns. So this is called action-based. Like, what do? You will be authenticated based on your actions, like the way how you type the password. Everybody has a different typing speed. So let me explain you. For example, if I steal somebody's username plus password, and let's say if they use, beside knowledge-based authentication, they also use action as a second factor of authentication. So even if I know username and password, system will not let me in. Let's say I have stolen the password and I want to try to get in. They know the username and password are fine, but typing pattern, they just put a flag. Typing pattern didn't match. This is basically the power, like the second factor of authentication. So what will happen? They might ask you secret question or something like that. So when we use 2 or more factors to perform authentication, like 2 or more factors to perform authentication, it is called multi-factor authentication. Like if you use knowledge-based authentication plus the token, it is a MFA. And this is what we use here at GGC. Multi-factor authentication, after you put username and password, system authentication server send you a PIN code on your cell phone. They expect that if it is you, you should have a cell phone as well. That's basically multi-factor authentication. Another example is like ATM card. If you want to withdraw cash, you have to have a card which is token, and then they will ask you to enter a PIN code as well, which is knowledge-based authentication, something you remember. So that's ATM card is one of the example of MFA. Okay. Now this is very important to understand. We know these are the ways how we can perform authentication. Then what is the role of this types of authentication methods? Like, I mean, we can authenticate by username and password, and that's it. We are good. So what are these types of authentication methods? What are these types? So the answer to this question is because these are application layer or application-based authentication. But the problem is, let's say, let me give you idea here. For example, let's say this is you and you want to, for example, let's say this is you and you want to get authenticated here with this server. So what will happen here, you will send username and password to access, for example, this particular resource. So you want to access this resource, so they actually ask you to enter username and password. Do you think you will send username and password in a plain text form? Of course not, because if you send username and password as a plain text form, anybody can sniff that and they can act like you. They can be authenticated. So what we do, typically we encrypt the username and password. And as you know, there are two methods to encrypt username and password. One is the symmetric encryption, asymmetric encryption, like public key, private key concept, or secret key. Let's make it simple, secret key. Now the thing is, you have encrypted this username and password using the secret key, okay, which is known only to legitimate AAA servers. So when this username and password will go to the AAA server, firstly they have to decrypt it. They have to decrypt the username and password. So when they decrypt username and password, of course, in transport layer, including session layer and all that, because I'm talking about TCP/IP protocol, they will decrypt username and password with the this key. They got username and password. If they have successfully decrypted username and password, you got first authentication. Like, hey, seems like it came from right person, because in order to encrypt username and password, you have to know the username, I mean the right key. Then after username and password decrypting username and password, then they will actually found a match. Then they will match it. So firstly, let me repeat. When you send your username and password, it will go in an encrypted form. So you have username and password, username plus the password goes in an encrypted form, encrypted with a secret key. Receiver will firstly extract username and password by using the same key. This is the first system level authentication, if they can successfully extract the right username and password. After extracting that, then they will actually found a match. Then they will compare it with the database. And then they will authenticate you. Like, hey, yes, this is you. So once they will authenticate you, it's kind of double of authentication now. Firstly, because they authenticate you based on the ciphertext, then they authenticate you based on, because they found a match. Are you getting the point? So let me repeat. Username, password, token, location, biometrics, whenever this data goes, it goes in an encrypted form. This is one of the example, by the way. When it goes to receiver has to decrypt it. When they decrypt and it got right decrypted with the right key, so you got first authentication. Then the second authentication, which is application layer. So transport layer to then application layer. Then it will go to transport to application layer, where they will match, and then they will let you know whether you are the right person or not. We will discuss that in detail. Just to give you, I just want to share this thing with you guys so you have understanding about what is the difference between factors of authentication and types of authentication method. So let's move to types of authentication method, transport layer. There are three ways how we can authenticate the messages or users, you can say, came from users or devices maybe. Three ways to perform authentication. The first method is called, first method is based on message encryption method. So we can authenticate the users based on the ciphertext. We'll discuss that. Second is called MAC, message authentication code. Message authentication code, we can authenticate the user based on MAC. The third one is hash. We can authenticate the user based on the hashing. The first is the message encryption, like how we can authenticate the user in the transport layer. Very simple. The example which I shared, which I gave you guys, it was basically based on that. So in message encryption based method, we use ciphertext as a authenticator. Or you can say we solely use ciphertext is used to authenticate users. How? Like this is the sender. Sender, for example, send you a message, encrypted message. It's a ciphertext. Receiver will use this ciphertext and authenticate the user, like whether it came from the right person or not. That's called message encryption based authentication. We will discuss that. Second is the message authentication code. The short form is MAC. It's exactly same as of hash, but here we use a key. We use a key, like a pre-shared key. A pre-shared key. It's a pre-shared key and something like that. This is a C, like just like a hash algorithm. We have this authentication function. C, and calculate the message authentication code. Let's say this is the plain text. With the pre-shared key, you got a fixed length result or fixed length code. This fixed length code is called MAC, message authentication code. So that's the message which you want to transmit. We calculate the MAC using the secret key or pre-shared key and pass it through. Let's say this is the message. You can see. Let's say that's the message. We will pass it from a function, authentication function, using a pre-shared key, and you will get the MAC. Okay, this MAC will be used to authenticate the user. Just like hash algorithms, it is irreversible. Irreversible mean if anybody get the MAC, they cannot extract the message out of it, even if they know the key as well. It's irreversible. Okay, so MAC is used as authenticator. Authenticator mean we will use MAC, message authentication code, to authenticate the user. We will discuss in detail with some scenarios. The last is the hash. I believe everybody's already familiar with that. We use hash for authentication. How? Let's say this is the message. We will calculate a hash of the message using, for example, SHA-512, MD5, these kind of algorithm. And you got a hash value, fixed length code, which is called hash value. And this hash value is used as authenticator to authenticate the user. So please remember this hash value, this particular hash value is again irreversible. It means if anybody gets your hash value, like hash code, they cannot get the message out of it. The only difference between MAC and hash is it does not involve a key. Does not involve key, like a pre-shared key, just like we use a key here in the message authentication code. So three methods to perform the to actually perform the authentication at transport layer: message encryption, message authentication code, and the third one is hash. We will discuss all of them with some scenarios, with some example, starting with the message encryption. So message encryption, some properties or some things that you need to know about message encryption. The first thing is, as we already talked about, ciphertext. We will authenticate the user based on ciphertext. So ciphertext is authenticator. Okay, let's make a scenario. For example, let's use symmetric encryption. For example, this is symmetric encryption. So in the case of symmetric encryption, I believe everybody's already familiar. Both sender and receiver, they use the same key. So we have private key or same key, private key, let's say this key, same for encryption and decryption, plus decryption. So both sender and receiver, they use the same key to encrypt and decrypt the data. For example, let's say this is my sender. and sender wants to send this message, this plain text message to receiver. Let's say this is our receiver. So sender, what's sender? It's a legitimate sender, so they know the key. And the algorithm, let's say this is encryption algorithm, that's the secret key. We have calculated the ciphertext message, which is encrypted. Okay, this is encrypted message. You can say ciphertext. Now, can anyone decrypt the message without knowing key? Of course not. So we got confidentiality here. We got confidentiality because nobody can see the message unless they know the key. When receiver will receive this, like this message, ciphertext, receiver will decrypt it, same algorithm in reverse fashion, same key, receiver will get the message back. Now when receiver will receive this particular message, what happens? We got confidentiality, number one. Number two, we also got authentication. Like we got the user authenticated. I mean, after that, we can actually make a comparison. Like it would be, the plain text would be a username or password. We can actually make a comparison here, okay, for double verification. But here, what happened actually, we got authentication. Why? Because only the person who knows this key can actually encrypt the message. Getting my point? This is the way how we are getting authentication. Let me repeat. We use ciphertext to perform authentication. How? Because only the person, the legitimate person know the key to encrypt the message. So we use, the receiver use the same key to decrypt the message. So if it got decrypted by using the same key, of course, the sender got authenticated because he knows the key. And then we can use, application layer stuff like knowledge-based authentication or, other stuff to validate over hypothesis. This is the called symmetric encryption, or that's by default. Symmetric encryption provide you confidentiality plus authentication at transport layer. Second is the asymmetric encryption. That's, for example, if we use asymmetric encryption. Let me recall the concept again. Asymmetric encryption, where we use public key and private key. So sender will have a public key. Let's say this is sender. Sender will have a public key and a private key. So let's say this is sender A, for example, and this is user B, for example. Sender A has a public key PUA, private key PRA, for example, PRA. He has a public key PUB and private key PRB. So if anybody wants to, this is our user A, for example. These are interdependent. If you encrypt anything by using sender or PUA, it can be decrypted by using PRB, private key. Or otherwise, if you encrypt anything by using private key, can be decrypted by using public key. Remember? So if sender wants to send a message to B, sender will use receiver's public key. So only receiver can decrypt it. Remember, like if sender wants to send a message to B, we will use public key of B, because if you encrypt anything by using public key of B, only private key of B can be used to decrypt it, or otherwise. That's basically interdependency. We already talked about it. Now let's say in asymmetric encryption, how we can get authentication. For example, this is my message and I want to send this message to my receiver. So let's say if I encrypt this message using asymmetric algorithm, RSA or something like that. So I will use public key of my receiver B. Okay. Now if I use public key of receiver, I got this encrypted message. Okay. This is my ciphertext. So let's see how we can use this ciphertext to authenticate and to perform authentication plus confidentiality. Now when receiver will receive this message, the encrypted message, receiver, because it is encrypted by using his public key, receiver will use a decryption algorithm. B was receiver, he will use his private key, get the message. Now very good. Nobody can see the message. If you send it wireless channel, if anybody see the message, unless they know the private key of user B, they cannot decrypt it. Everybody can sniff that, but they cannot see the content. So what we got confidentiality. We got confidentiality here. Excellent. But did we get authentication? Did we get authentication? Authentication mean, did user B authenticate that the message came from A? No, like we see the message, I just use my private key and I got the message. Yes, this is good. But how I could make sure the message came from A? Like anybody can send the message. Let's say C can actually use this key, your public key, and send the message. So we got confidentiality, but no authentication. How we can get authentication? Remember, like if we have a mechanism to verify that the message came from A. Let's see the example. For example, let's say we just want to actually get the authentication. So let's say this is the message. This is again my sender A, and this is B, receiver. That's the message. Sender will encrypt the message using, for example, his private key. Okay, so it can be authenticated. Now what happened? Message got encrypted because I have encrypted by the public key. When receiver B will receive this message, since this message was encrypted by using sender's private key, so receiver B knows the public key, because you cannot know the private key of other parties, but you can find the public key of each other. So sender B will use decryption key, use the public key of A, got the message. Now what we got here, I mean, what's the benefit? Benefit is that since the message got decrypted by using public key of A, so message came from A. So we got authentication here. We got authentication, but did we get confidentiality? We got authentication, but no confidentiality. Why? Because public key of A is known to everybody. If I am basically a hacker, sniff the message, I also know the public key of A, and I can also see what is the message. So we got authentication, but not confidentiality. In the previous case, we had the confidentiality, but no authentication. How we can actually get both of them? In order to get both of them, authentication plus confidentiality, there is a method or scheme which is called Jules encryption. And this particular method involved double encryption. The method is called double encryption. How we can get authentication plus confidentiality? So I want to actually get authentication plus the confidentiality, and I want to authenticate user based on just the encrypted message. So what I will do is, let's say this is my message. Sender A, this is A, and this is B. Sender A will encrypt the message. Okay, encrypt, because I want this authentication. So I will encrypt the message with my private key, PRA. And then after that, we got this ciphertext. But rather than sending it out, because we don't get a confidentiality, so I will encrypt this encrypted message again encryption, encrypt this with the public key of B. So only B can decrypt it. And I got this double encrypted message. I got double encrypted message. Now when the receiver will get this double encrypted message in the reverse fashion, this is receiver got this double encrypted ciphertext. The first step is receiver will, because it is, firstly we can decrypt it with, because it got encrypted with the public key of B. So private key, which is known only to B, will allow him to unveil the first encryption like we got here. Then in order to decrypt that and verify that it came from the right person, we will decrypt it. Sorry, this is decryption. This is decryption. We will decrypt it with the public key of A. We got the message. So now by you doing this, we got confidentiality. So only we know the private key. So only we can decrypt this false sense of, encrypted message. Now by doing this, like public key of A, we got the authentication, like because it got decrypted by using public key of A. So we got confidentiality plus authentication. So if you use private key of sender, he uses his own private key, it's kind of digital signature. But in digital signature, as you know, we involve firstly hash plus then encryption. It is kind of that stuff, because digital signature is the next step. Are you getting a point? So that was basically before the digital signature came in. Okay. So this is basically the authentication by using ciphertext message encryption. Next is the message authentication code. So message authentication code, also known as MAC. If you remember, we discussed we use MAC message authentication code as a authenticator. And the main difference between message authentication code and the hash function is it involves a key, which is a pre-shared key. Shared key. Again, just like hash function, MAC is also irreversible. Like the formula, something like that: C, M message and K. So C is the it's the authentication function. M is the message, and K is the pre-shared key. Shared key. Even if anybody know the MAC, whatever the answer is going to be, they cannot see the they cannot actually undo, or they cannot extract the message out of it, just like the hash functions. Now how we perform confidentiality, how we perform authentication, by the way. So let's say this is the sender, and sender will use this secret key, and receiver also has this same secret key. So let's say this is the message. Sender wants to send this message to receiver with MAC. So what sender will do? There will be two levels. First is just a message. Firstly, sender will calculate the hash MAC using the C, which is the message authentication function. Use the key and calculate the MAC, message authentication code, integrity check. And from top, we are getting just a message here. We will concatenate both of them, and we got here this message coming from top and the message authentication code. Okay, so we will send this message authentication code to receiver. When receiver will receive, this is receiver. When receiver will receive that, receiver got this box, message on the top and MAC at the bottom. Receiver will calculate the MAC of the received message using the same key. You got a MAC here. Now receiver will actually make a comparison of both of these MACs. If a match occur, then of course message came from the right person, like he knows this key. Are you getting my point? Because without knowing this key, how you can calculate the same MAC? So if the message, if both MAC they match, it means receiver sender got authenticated. So we got authentication here. But we didn't get the confidentiality. We are sending the message in a plain text form, so anybody can actually see the message. So confidentiality is not achieved by using this scheme. Now how we can achieve confidentiality plus authentication using MAC? So scheme, we need to revise this scheme a little bit. We have to use two keys here, two private keys here. This is the message sender. Now sender will know two keys, K1, K2. Receiver will have also two keys, K1. At least two keys are required. You can actually use public key, private key concept here as well. I don't want to confuse you with public and private key. Just assume that sender and receiver, they have two keys. They already know these two keys. So this is the message. Sender will again do the same thing, like you will concatenate. Everything else is same, like exactly the same. You will calculate MAC using this hash function. K, for example, K1 is used here. You got MAC here. Concatenate. Sorry. Okay, let me just draw at the bottom. So it's sorry about that. So let's say this is the message. So we have send the message at the lower exactly the same thing. We will calculate the message authentication code using key 1. We got MAC here, message authentication code. Now we will concatenate. This is the message plus the MAC, and we got the same thing like M and MAC. Now we will encrypt this again one more time, and we got here by using K2, and we got here message plus the MAC encrypted. It's exactly the same thing, just we have added another encryption step by using K2. Now when receiver will receive it, this is the message. receiver, that's the message, MAC, and this is encrypted with K2. Now when receiver will receive it, receiver will use his legitimate receiver, of course, knowing all these both key, will use decryption key and K2, and you will get the, again, message plus MAC. We will calculate the MAC for message by using K1, and we got here MAC. Now it's time to make a comparison. If both values match, user got authenticated, sender got authenticated, other was not. And we are also got the confidentiality as well. There are a bunch of ways to do that. Like there is another option. You can actually encrypt this message, encrypt the message first with K2, and then calculate the MAC of the message, and then send and concatenate encrypted message plus the MAC and send it to receiver. But that's a simple way to do that. If all you have to do is just receiver has to know these two keys and sender will use these two keys. First is to calculate hash value or MAC. Second is basically for encrypting the message plus MAC. Okay. The last method is the so in authentication using hash algorithm or hashing, we use hash value. We use hash value as authenticator. We use hash value as authenticator, like we will calculate the hash value, and based on the hash value we can authenticate the user. How we can get it done? So like hash value of the message, whatever you will get hash here, we will use hash to perform authentication. How? Let's say this is the message and we want to actually authenticate the user using hash. So what we will do is, from lower end, what we will do is we will calculate the hash of the message. Let's say you got some hash value, also known as message digest. You got this hash value. Now we will encrypt this hash value by using sender. Let's say sender is A. Sender's public key, private key. Sender A's private key, like, so everybody can verify it. Now we will concatenate the original message with this encrypted hash value. Like this was a hash value. So it got encrypted. Okay. And this is the message which is coming from here. We will concatenate both of them, like combine both of them, and we got message with hash value but in encrypted form. Now when receiver will receive that, let's say this is what receiver will receive. Receiver will get this message plus this hash value which is encrypted. Receiver, what receiver will do? Receiver will first calculate the like from the top end. Receiver will actually calculate the hash of the message, and you get, let's say, this hash value. And from lower receiver, it's encrypted with the private key of sender. So receiver will decrypt it with the public key of the sender A. And after that, what you got this hash value. And as you know, we cannot undo hash value to get the message. Now we will make a comparison. Now, if both values coincide, it means you got message came from the right person. So what we got here, we got user authenticated. But the question is, we got authentication here, but did we get confidentiality? Like if you see, the message goes in a plain text form. All we did is we are basically authenticating the user based on this hash value. How? By encrypting this hash value with his private key. So if you encrypt anything by the private key, can be decrypted by using the public key. And everybody knows the public key of the sender, like A. So what we did is we calculate the hash of the message. Okay, and encrypt the hash by using private key, concatenate with the message and send it to receiver. When it gets to the receiver, receiver will calculate the hash of the message using the same algorithm and decrypt this encrypted hash by using the sender's public key. And we got this hash here. If both values coincide, message came from the right person. Why? Why came from the same person? Because we got the same hash at the end. And it got decrypted by using public key of A. Because it means that it has been encrypted by using private key of A, which only he knows. Confidentiality is achieved, but authentication is achieved, but no confidentiality. To get confidentiality plus authentication, slightly we need to make a change. Everything else is exactly same. What we're going to do is We just have to sender A. So everything else is same, and sender A, let's say this is sender A and this is, for example, sender B. So they just have to pre-share a secret key first. Okay. So secret key, and let's say everything else is same, exactly the same model, but we will just encrypt the message with the private key. Okay. So how? Let's say this is the message M. We will encrypt the message with this secret key K. We got the encrypted message. From here we will again calculate the hash value. We got this hash V, for example, hash value, and then we will encrypt this hash value by using private key of A, exactly the same way, private key of A to get the authentication, private key of A. And after that we got this hash value which is encrypted. We will concatenate encrypted message coming from the upper layer, upper connection. We got now message fully encrypted and the hash value just for authentication encrypted. Now when receiver will receive that, this is receiver, what receiver got, message encrypted and hash value which is also encrypted. So what receiver, for message, receiver will decrypt the message using his pre-shared key and then calculate the hash value of the message. You will get some hash value here. Now from this, decrypt it using public key of A, because it is encrypted using private key of A. When you do that, you will get the hash value. Now just make a comparison. If both values coincide, you got confidentiality. This will provide confidentiality plus authentication. Why? Because it got decrypted by using public key of A. So it means that whoever sent this, he knows the private key of A. Everybody got it? So let me just give you, let me walk through it. So what will happen, how we will use hash function as authentication here, authenticator here. Message is encrypted by using a pre-shared private key, which receiver already knows that. We encrypt the message, calculate the hash value of the message, encrypt it by using private key of A, like the senders, so everybody can verify it, concatenate encrypted message and hash value. Receiver will receive it, decrypt the message first. We got the message here first, and then calculate the hash of the message. If it is the right message, of course, you will get the right hash value. From below, we will decrypt the hash value by using public key of A. We got the hash value, make a comparison. We got, if the both values are same, no, sender and receiver both got authenticated plus confidentiality as well. So this is all about chapter number 4, part A. We have discussed 3 methods to perform authentication. We have mainly discussed the message encryption method. We discussed message the message authentication code, and we have also discussed the hash algorithms. So we discussed the definition, factors, which is application layer. Then we discuss how we authenticate a transport layer and stuff like that. So last, which is the formal authentication protocol, we will discuss that in the next video. If you guys will have any questions or didn't understand any concept, please send me an email, or we will discuss that in our face-to-face class as well. Thank you very much, and see you guys in next class. Bye-bye.